Hello, my name is Jordan Stiver, and I'll be presenting on our paper titled The Rapid Naming Test, Development and Validation in Typically Aging Adults, with my co-authors here from the paper. And a big thank you to the Student Affairs Committee for this wonderful opportunity to present our work on this new test. So just a little background. So word finding difficulty is a prominent and frequent cognitive complaint among healthy older adults. As we age, word finding becomes more challenging and can be a source of social anxiety, embarrassment. Word finding difficulty, of course, is also a symptom of pathological aging, such as in Alzheimer's disease and other neurodegenerative diseases. However, our classic confrontation naming tests, they can be lengthy, in some cases up to 20 minutes to complete a single test. And they were designed to detect impairment. So distinguishing folks with anomia versus not, as in a patient with a stroke or what have you, but not necessarily a normally distributed marker of naming ability per se. And so as such, they do tend to show ceiling effects among typically aging adults. And this can pose a problem with regard to over-pathologizing. Say if somebody were to get a score that's maybe just slightly below the normative mean with such a heavy skew, that score could potentially be over-pathologized. So all of these points highlight the need for an efficient naming test that is sensitive to the more subtle, just typically aging-related word-finding decline that we see so often. So the purpose of this study, again, we wanted to develop and validate a new naming test according to a novel paradigm among healthy older adults. So along with that, our aims were to assess the psychometric properties, including the score distribution. We wanted to test the association with demographic variables, including age, examine its relationships with other measures to determine evidence for convergence and divergence with other neuropsych measures. We wanted to test its relationship to subjective language decline, so self-reported word finding difficulty, to get at the ecological validity of the measure, and to test its relationship with an Alzheimer's disease biomarker, amyloid beta, and finally to determine test-retest reliability. So to develop the test, we utilized the stimuli available through the International Picture Naming Project and the Bank of Standardized Stimuli. These were big repositories of stimuli that were normed on healthy adults. So we were able to collect information on name agreement from these repositories and set specific criteria. So the selection criteria we utilized was a name agreement of 85% or higher. We wanted there to be little ambiguity as to what people were calling these items. A word frequency of less than 5 per million to make it somewhat difficult. And these were data based on online corpus to get the word frequency per million based on English subtitles is what the corpus determined the word frequency based on, and an age acquisition of greater than 5 years old. So we set these criteria after, lengthy amounts of piloting of various levels of these variables, and really chose the criteria that gave us the best possible sort of distribution of scores, and likewise limiting the ambiguity of items. And so as far as how we arrange the stimuli in the test, we arrange them in such a fashion to minimize item-to-item priming or interference. So, keeping the simultaneous items separated semantically. So no two items were from the same semantic category, for example. No two target names rhymed or started with the same phoneme. So that sort of thing to limit item to item effects. And we evenly distributed the difficulty throughout the test based on the word frequencies. So these were sort of randomly arranged, and we ran a runs test of non-randomness statistical test to confirm that the difficulty level was sort of randomly dispersed throughout the order of items. As far as administration, participants were instructed to essentially name as many objects as they could in 60 seconds. So they were to name each object as fast as they could. Each line drawing was presented on screen individually, and the examinee would provide a response, at which point we would advance to the following item. And there was a 5-second limit per item, no cues. And so participants would advance to the next item either immediately after they uttered a response or after the 5-second time limits, whichever came first. And they named as many as they could in 60 seconds, and that was the total outcome score. These were our participants. We recruited 145 typically aging, functionally intact older adults via case consensus. This was through the UCSF Hillbloom Healthy Aging Project, the longitudinal study. And we also recruited a younger adult sample in New York City. These were young adult college students, 69 of them. And they only completed the rapid naming test. So moving forward with the rest of our procedures, they will only pertain to the older adults. The younger adults were just for a means of comparison, and the younger adults were recruited through a parent study on sleep, light exposure, and cognitive function. So as you can see, the older adult sample was, well, they were very well educated, and they were primarily non-Latinx white. With our younger adult sample, they were also primarily non-Latinx white, a little bit better balance in that regard, but still mostly non-Latinx white samples here. And the larger proportion of females for both groups as well. This was the neuropsych battery. Again, moving forward, this all pertains to the older adult sample. They completed a comprehensive battery across these 4 domains. So the BNT short form, that was one of Mack and colleagues' short forms, the 15 item. The word reading subtest from the RAT, a 5-item repetition test, phonemic fluency, semantic fluency, learning and memory, the CVLT and the Benson complex figure. Visuospatial, we did the VOSP number location subtest, and we had the Benson complex figure copy in that domain, and some pretty standard attention, speed, and working memory executive tests. They also completed a comprehensive processing speed battery that led to a composite Z-score, and the higher the Z-score indicated worse performance or slower speed. And this has shown evidence of validity in cognitively normal older adults. We did a self-report measure, the ECOG of subjective cognitive decline. For the purposes of this presentation, I'm just focusing on the language subscale. So they rate compared to 10 years prior, how much they've declined within the language domain across several items. A subset of 44 older adults completed amyloid beta PET imaging as well. Imaging was acquired at UCSF and processed in accordance with the ADNI protocol. So we obtained SUVRs and converted those to centilloids to improve consistency across other studies to have centilloids. Okay, so we'll move on to the results. And to start, the score distributions are shown here. We see the rapid naming performance among the older adults and the younger adults here. So the averages for the older adults averaged about a 34 out of the 65 max total, and then the younger adults scored a 37. There was a significant difference between the two groups. And as we see, nobody in either group hit the floor at a 0, and nobody hit the ceiling, a perfect 65. So we had a nice normal distribution of performance. And this is in contrast to the Boston naming test, which did show that negative skew, totally consistent with prior literature on sort of the classic naming paradigm. As far as relationships to demographics, in the older adult sample here, we did see a fairly strong relationship with age. In older age, worse performance, and no relationship with sex and education. And in contrast, with the BNT, we did not, just as a means of comparison, we did not observe a relationship with age for the BNT in this sample. And we did see that it was perhaps confounded by education. So it did show a relationship with education, which would be consistent with prior literature showing relationships between naming tests and things like vocabulary and premorbid intellectual function. In our younger adult sample, it was a very, very limited age range, roughly 18 to high 20s. So we did not see a relationship with age there like we did with the older adult sample. And likewise, no relationship with sex or education in the younger adults. And this is just to indicate the difference in performance among the younger and older adult samples. So there was an effect size that was sort of moderate comparing the two groups. So a group difference and a correlation with age within the older adults. So it was related to age, as we were expecting. And we'll move on to the rapid naming test relationship with other standard neuropsych measures. Starting with the language domain. And as we can see, this is consistent with what we hypothesized, that it did relate significantly to all of our language measures. So sort of reflecting those sort of temporal processes. And we do see the strongest relationships with the Boston naming test, reflecting sort of lexical access and retrieval, and animal fluency. So that was important to see that those were the strongest relationships out of the language domain. So the y-axis being the strength of the correlation. For measures that were significantly skewed, so the BNT and repetition, for example, we used Spearman-Rowe, but otherwise these are Pearson-R coefficients. So this is learning and memory, and consistent with prior literature implicating the hippocampus in naming performance. We did see relationships with learning and memory measures, specifically visual memory retrieval, as well as verbal learning and memory measures from the CVLT. And no relationship with the visuospatial measures. So that was also good to see as far as evidence for divergent validity. And as far as speed, executive, we largely saw relationships with measures relying on speed. So given that it is a speeded test, this makes a lot of sense and falls in line with what we were expecting as far as being related to trail making and Stroop color naming most strongly, sort of a basic speeded naming test, as well as the Stroop interference test, which we know is speeded as well. We included a ratio for Stroop interference and color naming to sort of extract a more sort of pure executive measure there, and it was not related to that. So in thinking about the Stroop relationships, it really does seem to be specifically related to the speeded aspects of the Stroop test. So this slide here is just to summarize and flag the various measures that the RNT showed a significant correlation with. And as we can see, you know, language, learning, and memory, some of the attention and largely the speeded tests. And so what this really reflects is that the rapid naming test, a lot of different abilities contribute to its performance, you know, speed, a lot of the language, perhaps some of the learning and memories reflecting the hippocampal function and its role in naming. But naming is really not a unitary construct, as we can see by this. It's really a construct that includes many different component processes, from, you know, from recognizing an object, accessing the semantic properties, pulling together the lexical information, and sort of programming that for motorically uttering a response. So it's very much a complex process, confrontation naming. So as far as subjective language decline, we looked at regression models, and we noticed a significant relationship between rapid naming and language decline. This is a negative relationship, so the greater the performance, the less report of decline. And we wanted to test whether it would hold up after controlling for the Boston naming test. So that is, does it show incremental validity in predicting subjective language decline over and above the BNT? And we did find that. So the rapid naming test does predict language decline over and above the BNT. And interestingly, in this model, the BNT shows the reverse relationship than what we'd expect. So the greater the BNT performance, the greater the report of subjective language decline here. So this was unexpected, but, you know, statistically, perhaps what we're seeing is that the rapid naming test is sort of gobbling up all that variance in the expected direction. And then what's left from the BNT is sort of the other direction. So we see that kind of a flip here, sort of a statistical anomaly. We also wanted to test whether the rapid naming test is really just serving as a proxy for speed. So we controlled for speed as well. And fortunately, the contribution of the rapid naming test continued to hold up even after controlling for speed. So there does seem to be something unique about the naming component in rapid naming that is continuing to predict subjective language decline beyond speed and the classic naming model. And as far as amyloid beta PET, so an Alzheimer's disease biomarker, we see the same type of relationship. So just like subjective language decline, we did see a relationship with rapid naming, and incrementally over and above the Boston naming test short form. And likewise, the result held up after controlling for speed as well. As far as test-retest reliability, we had a subset who came back and completed the test for a second time. And we saw good reliability, so an R of 0.86, so that was reassuring. And we'd like to replicate this with a larger sample, of course, and perhaps a less variable interval between tests. Okay, so in conclusion, the rapid naming test, it showed a good normal distribution. It showed good test-retest reliability, so it does seem to be tapping naming ability per se, and showing a good range of scores. Our older adult sample performed worse compared to our younger adult sample, and within our older adults, older age was associated with worse performance. Performance among the older adults showed good correlations with tests we would expect it to correlate. So language tests, most strongly semantic fluency, and the Boston naming test. Some of the learning and memory measures, and of course our speeded tests. And so that's good evidence for convergence and divergence from other tests. And lower scores were related to greater subjective language declined, so evidence for ecological validity. And lower scores were related with greater amyloid beta PET imaging, so suggesting we may be seeing a relationship with pathological aging as well as typical aging. So for future directions, we want to focus more on testing patient groups as well as typically aging groups. We'd like to see how well it discriminates patients from controls, and also within patients, how does it discriminate those with and without anomia? So can it be that specific as well? And to test more diverse samples as well. This sample was primarily non-Latinx white, so we did not look at effects of ethnicity and race. We were not able to, but more importantly, in studying diverse samples with this measure, we do want to look at different sociocultural variables and how those are really driving relationships. So both sociocultural diversity as well as linguistic diversity. So in New York City, we are continuing to administer this measure in diverse samples and try to get a better characterization of the correlates of performance on rapid naming with regard to sociocultural variables. We've moved the test to the iPad to further improve the efficiency of administration. And I've listed the URL here for anybody interested in administering the test as part of their own research, or if they just have any questions or are looking for more information. So the iPad version is available on the TabCat platform. That's the tablet-based cognitive assessment tool through UCSF. So it's part of that suite and freely available. We have Spanish and Portuguese versions as well. We are looking forward to validating those versions. We're continuing to work on those. And we want to be able to test longitudinally how well this might predict conversion to, say, MCI or dementia. And we'd also like to test neuroanatomical correlates as well. The majority of our older adult sample did get neuroimaging as well. So we do plan to dive into that as well and look at the neuroimaging correlates of performance. So thank you all for your attention. Big thank you to our participants. Thank you to the team over at UCSF. These are my colleagues at the UCSF Memory and Aging Center, where I used to work. And big thank you to the Fordham team as well, where I am currently for graduate school, and where we collected the young adult data. And my mentors, Dr. Kramer, Dr. Gorno-Tempini, Dr. Zimmerman, for all their help and support. If anybody has any questions, feel free to email me as the corresponding author on the paper. And like I said, that URL is listed as well to get in touch with the TabCat team. So thanks again, and take care.